Please welcome Joe Meersman.
Morning, everyone. My name's Joe Meersman, and I recently left IBM Design after spending about a good 6 years helping to build the largest design organization, as far as I'm aware of, on the face of this little spinning mud ball. I recently left about a month ago, and I started as a user experience design director at an IoT company by the name of Resideo, where I feel like I'm privileged to have the opportunity to help address global warming via behavioral nudges. When I talked with Allison, one of the conference organizers, about hosting a panel and what we were going to call it, I felt like there was an exciting opportunity to address data, design, and then again data. And I'm really, really lucky to have my fellow panelists who are going to be joining me here on stage. The first of which is a extremely talented user experience designer by the name of Marijke Jorritsma. And I'm kind of jealous, to tell you the truth, in that her work is actually going to be taking mankind to Mars and beyond throughout the span of our lifetimes, right? Throughout the rest of our remaining quarters. So I want to welcome Marijke to the stage. And then we're also joined this morning by an extremely talented designer / data scientist by the name of Dean Malmgren. And he's an executive portfolio director at IDEO. And previous to that, Dean was the co-founder of a company by the name of Datascope, which was acquired by IDEO a few years ago. Dean, please join us on the stage. And what we're here to talk about is kind of the intersection of data and design and how that's going to affect the careers of not only all of us in the room, but also our industry writ large. In addition to kind of that higher level topic, we're going to end things with some pragmatic takeaways that everyone in the room can kind of roll into their career and integrate into the way that they work and how we leverage data. Before jumping in, I do want to thank the organizers at Core77 for having us here on stage, as well as putting together a really fascinating kind of series of talks. So I'm gonna run through thanking Allison, Stu, Laura, Deb, Alan, and Eric. And to kind of kick things off, I was really inspired by hearing Yasmin talk a little bit about code switching. And I think that we can kind of leverage that as a jumping off point in our conversation. But I also want to thank John for referencing like dead mentors, which was a really nice contrast. I don't know where things are going to go from here, but I'm pretty excited about them. I don't know about all y'all. So I guess kind of to start things out, Dean, as someone who is, I think, self-represents as a data scientist but works inside of a design organization, what does code switching mean to you?
Yeah, I was really inspired by Yasmin's talk. I mean, among many other reasons, describing the need to have a common language for how we communicate. As a data scientist, trained in machine learning and doing all kinds of data analysis as a PhD student, that was really important for developing that sort of interdisciplinary collaboration. And it's become ever more true as we've joined IDEO, having a common language around design, how we make things, how we communicate those ideas with our peers and then collaborate on them in really constructive ways is challenging, particularly for data scientists who naturally find themselves behind a computer screen, typing like monkeys, or at least that's the image that people have in their mind, and getting them out in the world and learning from people, developing empathy and designing algorithms accordingly. So I love that code switching context.
Yeah. And Marijke, your interpretation?
I also similarly resonated with the idea of developing a shared language. At JPL, where I work, most of my users are collecting science data, or data science, science data.
It's confusing.
Data for science. to understand the exploration
let's
of the
go with
universe. And so a big part of building trust with them is developing a shared language, being able to demonstrate that I can understand their concerns, and just speak the same language as them. So I really resonate with the idea. And part of that is taking what they're talking about and organizing it in a way and showing it back to them. So I like the idea of creating these collections of words or collections of strains of sensory collections. Because that's sort of a way that you then can start to demonstrate an organization and build an alignment, possibly, in what you're seeing. It's like an early prototype of sorts.
Mm-hmm. Do you mind kind of running through maybe an example of how you've been able to kind of leverage that approach, that philosophy, and work it into a project?
Yeah, I mean, so most of the time, in order for me, so the users I work with are scientists who are usually designing an instrument that's going to be on board of a spacecraft. And I'll be working with tools for them to understand their data or command the spacecraft to collect more data. So in that, just understanding their use cases usually involves understanding some element of the science they're trying to achieve, so that I can then get into the place to even empathize with them. I have to understand what the tensions in their domain are. Sometimes so JPL is in Los Angeles, and I liken it to what it's like when you have lived in Los Angeles long enough that you can argue about what freeway to take. It's sort of like the sign that you've become an Angelino. And so similarly, like I have some recordings on my phone when I'm able to actually talk to the scientist about the challenges of collecting or measuring certain ions in the atmosphere and what the tensions there are, because that really is what you're trying to help make easier for them in some way. And they're not going to be able to necessarily communicate to you what the software, the user experience for that software is going to be, so you have to do a lot of interpretation in that way.
Kind of switching over to Dean, like how would you say that that compares to some of the project work that you've done, and maybe how that's affected your approach as a creative problem solver?
Well, the thing that I think is really interesting about Marijke's user set is that your scientists natively speak the language of data.
Yeah.
And I'm a data scientist who speaks that language fluently, but have had to coach other data scientists to learn the language of design.
Right.
And the reality is that the world writ large is awful at the language of data. And in fact, they're dreadful at understanding models, understanding predictions. In fact, models are often wrong, and so designing for that context and how they can fail gracefully is a real challenge. So there's definitely a difference there, I think, in our experiences. For us, it's about communicating things in an authentic way, making sure that people understand the give and take of what we might suggest or recommend, and be able to design the context in which you might absorb that to make better decisions and design better products. So it's interesting, like designing for scientists versus the average Joe off the street. No pun intended.
No, it's cool. It's never happened.
I do want to jump in there and say that even though I'm working with people who are very skilled in their relationship to data, that sometimes they're not skilled in their relationship to other people's data. So, and I would say 90% of the work that I do is getting people from one very specific domain to be able to understand the complexity of someone else's domain, because if you can take this PhD and multiply it by all these PhDs, then we're going to be able to advance what humanity can do in general, which I think is the overall benefit of getting people to be able to understand or simplify data, is being able to sort of leverage this knowledge. So there are similarities, but they are generally skilled in understanding data.
That's fair.
Dean, you mentioned failing gracefully. And you know, as a very popular yet somewhat populist notion, there's the entitlement behind like failing fast. Mm-hmm. I'm just kind of curious, I'm a data scientist and designer here on stage who work to kind of interpret between those two spaces. Is there a difference between the way a data scientist fails fast, fails gracefully, and the way like a designer might fail fast?
Yeah, I would say so. Although I'm going to now advise them to read John's recommended essay. I think, yeah, so when we're designing algorithms, the fact of the matter is there are any number of different ways to tackle a challenge and make a prediction. And typically during a project, we'll throw 50 models at a problem to see what works, and based on that, use that to infer how we might make that experience even better. It might even inform the service that we're designing, or the experience, the interface. And so the point of that is putting our hypotheses out there, seeing what works, and quickly learning what doesn't, so that we can get smart about how we're sort of designing that holistic thing. Trying to think of a good example. We were doing this work for a national bus company, and they're in their business. They basically have two levers for winning contracts. They have the lever of cost, and they have the lever of safety. And so we worked with them to try to identify new ways that they could help bus drivers drive children to school more safely. Every year they have a 3% per year goal in reducing the number of accidents per year. And the reality is that they only have a couple of levers that they can pull. They can either fire somebody, or they can train the whole depot, and that's it. And so, as you might imagine, they have a retention problem for some reason. And so we went ahead and designed, we actually used that as inspiration for how we might design interventions or services to improve bus driver safety. And the biggest question that we had was whether we'd even be able to predict when a bus driver might have an accident in the first place. And so we took some data that was really easy to get access to. It involved the pre-trip check data. So before a bus driver takes a trip, they have to go around the bus with an RFID tag and check to make sure the windows are closed, that the tires have the right pressure, and so on and so forth. And one of the things that we learned really quickly is that people do that in a very different way. Some people use that as an opportunity to have a smoke break. Others run around the bus really quickly, listening to the radio, and just get on and get out of the bus depot. And so we had to design models that were very personalized to those individual bus drivers' circumstances to improve safety. And some of the earliest models that we were trying were actually not in that way. And so we were thinking that everybody was behaving the same, and so we could just kind of throw everything in this black box and it would just work. And that didn't work. And so using that as a way to get inspired about how to understand those personal nuances was really, really important for actually designing something that could anticipate upwards of 20% of accidents. The tragedy is that we didn't end up getting to take that work forward because there was a bus accident in the jurisdiction of our main client, and he was fired. So that's sad.
Yeah, I don't like the way that story ended.
Sorry.
Marijke, if you could kind of pivot this.
Yeah.
And,
let's talk about Mars, maybe.
Were there any assumptions that maybe you've made about the way scientists are going to interpret or otherwise manipulate data that you think the audience could benefit from?
Yeah, I mean, so I guess one of the assumptions that there's a lot of, I guess there's an assumption that there wouldn't be sort of social bias in the way that they look at data. And by that I mean that they're not looking at it objectively, but that they aren't affected by social dynamics when wanting to interact with their data. So right now I'm working on some tools for automated spacecraft planning. And in that, we're using models to simulate the mission. It's the Europa Clipper mission, so we're sending a spacecraft to the moon of Jupiter to study whether the moon has the conditions to support life. And my ideas about designing user interfaces so that they could simulate things based on priority amongst a bunch of different scientists. So we could say, this instrument has really high priority because it's going to be the one that's going to be taking the high resolution color photos. And this one over here maybe has less priority because it's going to be a dust sampler, and we're not going to be flying by any dust at this time. That they could handled that level of conversation about priority was an assumption that I made. And so, but what I realized was that when talking to scientists about prioritizing their data, that in fact was something that was not, that it was very subjective and very personal, that it was something that it's like asking someone to prioritize their baby. And so it's just, they can't do it. It's their job is to get the data for their instrument. So, and even that right now is an assumption that I'm testing, because we understand as a mission that we need to not look at data as proprietary. That's something we're working really hard on right now. So even in the way that we talk about, we're prohibited from using on this mission the word our data or your data or the data of a specific instrument. And so, yeah, that's where I am right now. Can we design for people to look at collecting data collaboratively without thinking about it as their own? I think that these are issues in the science community at large. So yeah.
That's great. When it comes to the notion of like all things third wave, and when I think about Alan's opener, I'm interested to get both your perspectives on the nature of like human-computer interaction and the fact that we as humans are evolving, a lot more signal, a lot more noise out there, as well as the notion of, you know, with all things quantum computing, the notion that a computer is also evolving. So how does that affect that human-computer interaction?
Yeah.
I mean, for me, I get really excited about this topic. So we see data and design intersect in a bunch of ways. There's using data to quantify design and understand whether a design is impactful. There's using data as inspiration for design. So maybe simulating future states, getting a sense for what the realm of the possible could look like. And then there's using data as a medium for design, where we're creating these massively customized and personalized experiences. When I think about those challenges, one of the things that I'm always drawn to is designing the simplest possible thing that has actually a positive impact. All too often we lean too heavily on technology to do all the work for us, and we've seen a lot of success in helping people see the unseen through data, but then giving that information to people to make good decisions and provide really great services, experiences, whatever. So I don't know, that's what comes to mind for me. I'm curious about in your experience, though.
Yeah, so when we started talking about doing this panel, it was actually a little bit hard for me to understand what Dean was talking about, because I mean, we come from a different perspective. I'm a designer, he's the data scientist, but also I didn't understand what he meant when he was saying data as a medium for design, because my users, their whole industry or their whole work is about using data as a design medium.
Well, you said it was their babies.
It's their babies, right? But I mean, space exploration is about collecting, for us as a science organization, it's about collecting data. And so that's what my users have been doing for 70 years. So in a certain way, I think that maybe this is an example of who the users, maybe the people who are starting to just get into the idea of collecting data, or that they can collect data, maybe this is what we'll be thinking about for them later. However, with the science community, because we have so few opportunities to send and collect science space data, I think that industry has probably evolved really slowly. So I have users who have very sophisticated relationships with data, but their idea of maybe the software or the applications or the experience of how we can transform it has really changed. So one of the things, so I have these users, and they're at the point where they're really comfortable with the idea of simulating and modeling things. However, designing, and so that's the area where I'm really thinking about what the future is for them. And as a designer, it has a lot to do with what I call human-computer collaboration. And this idea is that trying to figure out in this dynamic, and I say collaboration not because I think that these models that we build are so fantastic and amazing that they're gonna become like a human themselves, but really because it's a different kind of relationship than building something like an interface that you're just interacting with, because the user interaction is about describing behavior. And I like the word collaboration because I think when I think about two humans collaborating, I think that there's this element of trust that happens, that I look at this other system and it's a bit opaque to me, but I know that if I interact with it in a certain way and that there's an output, that I can trust it and we can collaborate. And in some ways, that is the metaphor that I'm thinking about with my users who are working with these models and trying to figure out what the ideal collaboration possibility could be. And so I've been kind of investigating that also, like at JPL, but also looking at how artists are starting to work with like machine learning. And I think that there's some really interesting strategies that I see emerging. And I think Yasmin was also maybe talking about this a little bit, the collaboration. This idea that, and again, these models, they're not perfect. They're really sparse in lots of ways. But that there's sort of a mirror or a reflection of behavior. And in that, you start to understand what it is that makes being human very unique, what the subjectivity and bias is. And maybe in certain ways, that is our strength. That is the thing that leads you to realize why you come up with a hypothesis over and over again, or why, as an artist, your particular path is very creative. So as designers, it's then trying to figure out how do we get them to realize how do we build interfaces that support that specific human-computer collaboration dynamic.
To pick up on that, I love that trust issue, which I think is, I mean, it's so fundamental to when you're making a prediction. You have some error bar on what you might anticipate happens in the future. I love to pick on weather forecasts. It's like easily my favorite thing. It seems like they always get it wrong, at least in Chicago. And so when they say, you know, it's a 30% chance of rain today, that means actually something dramatically different than there's a 30% chance that it's going to rain right now. And so we have icons and we have other ways of explaining what that means so that people know whether or not they need to take their umbrella in the morning. And that developing trust with those intuitions is kind of fundamental to how we design intelligent products and services in the first place. So that feels like such an important part of it. And then doing that in an ethical way that doesn't, I mean, when you're collecting data and you're using it in lots of different ways, there's all kinds of real ethical challenges that come up, and making sure that you're not obviously offending underrepresented groups, making sure that you're being honest with your degree of certainty on things, but also expressing confidence when you have the right to do that. So there's an interesting trade-off there.
Yeah, what I took away from that was you love trust issues, which I think makes things a little complicated for Dean in the workplace. You know, we can, with the name of the panel being design and data and design, I don't know about everyone in the audience, but I didn't get into design because I was good at math. And I think it's important that in the remaining time that we have here, we provide some, we get a little bit away from strategies, and we get a little into tactics as far as, you know, throughout the rest of our careers as designers and as educators and as leaders, we can learn to be the best possible collaborators, not only with the computers and like these abstract models, but also with the data scientists and the data engineers that we're meant to work with. So if we could hone in on a few things that are actionable, I think that'd be beneficial.
Well, I mean, there are a lot of things that I think are really beneficial for collaborating in this context of designing intelligent things. One of them is shared language, and we kind of already touched on that already, and just having a mutual agreement about what language you're using and why, and sometimes it needs to be scientific, sometimes it actually needs to be a visual language that we can all understand, and having the empathy with the people that you're talking to bring that to life. So that's one thing that I would recommend. The other is that, you know, when we design intelligent things, you look at an intelligent system and it does really three things. It senses the environment around us. takes all that information, it takes an action, usually on your behalf, or sometimes it just presents that information to you and you take the action. And then down the road, it actually learns from that action that was taken, and that which then informs like how that whole system works and makes it smarter and more personalized and changes to your context over time. And that framing of sensing, acting, and learning is actually an awesome design exercise for teams to do, to think about how you might create services that fulfill that. So you can start to map out when you're collecting data at different points to inform models downstream. So those are some thoughts.
Yeah, I think that for I'm going to make 2 recommendations from a very design perspective. The first is do some homework and try to learn as much as possible about what it is that if you're collaborating with a data scientist or a machine learning developer or whoever your technologist is, do some research to understand what their tools that they're painting with in a way are, because then you can start to have some really engaging discourse and you can apply your design thinking process to scaffolding a data science project, basically. And it just sort of strengthens that collaboration and is going to make that collaboration with who you're working with really solid. And then the other one is these are exciting data times, and we can do a lot with data, and we can collect all this data, but it always goes back to finding a really good problem to solve. And in fact, that is almost the starting ground, is find a really good problem to solve and then use that knowledge that you've gained by doing your homework about what you can do with data scientists and that strong collaboration that you have with the technologists to solve that problem.
These are really exciting data times, I guess. It's also like a terrifying data time in many ways. And one of the things that I frequently find myself discussing with many of our clients is there's this big promise of big data and AI, and it's going to save all of us and maybe make our worlds frictionless. And that feels just so flawed in many ways. When we're designing new things, new to the world things, it's very rare for the data that we already have to actually be valuable. Usually that data is collected for operational reasons. And so while it may be valuable from an operational point of view, it's not often useful for new customers or new customer experiences. And there seems to be this big disconnect between like hoarding data and actually having the right data to begin with, let alone doing something useful with it beyond that. I'm curious, because you mentioned when we were thinking about all this, how NASA's has data going back 50 years. I mean, that's amazing and so important for scientific discovery.
Absolutely. I mean, all of the data, so we have very limited hardware space. So everything, the problems that we're going to be encountering in terms of realizing the impact of collecting endless data is something that we had to start with from the beginning, because we can't just collect endless data. So everything is very specific, and it continues to get more specific because the resources are so constrained when collecting data in space. So we do have data, but I think that all of that has been, it is continued to be mined for discovery, but it's not, I don't think it says, it could be more designed, and it will continue to be so. Yeah. But it's probably not as comparable to our terrestrial data collection modes at this time.
Yeah, I don't really know where to take things after someone says terrestrial data collection.
Makes me feel so small.
Yeah, me too. As far as resources are concerned that would allow designers to kind of quickly ramp up in the domain of data and data science, I'm kind of just curious, what you might recommend for people in the audience to kind of where they might go to learn more.
That's a good question. I mean, one of the things that was really useful for me in the beginning of understanding what could be done with data was going through papers about how people were using AI modeling and procedural generation in game design. It was something I was kind of interested in, but it was just like pulling out some academic papers in which I didn't understand any of the words that were being said, and then just forcing myself to understand, what is a Monte Carlo simulation? What is this? Why would someone do this? What problems are they trying to solve? So that's one thing. And then the other thing is, I think data visualization is a very popular topic these days, and a lot of people are using it in a popular kind of setting like the New York Times, but also obviously in science, data visualization is huge. And so when you're presented with that information, you could say, okay, well, this is being represented in this way. How is this data used? How could I keep going to keep proving things? And how would I go backwards to construct the collection of that data? So kind of creating little thought experiments for yourself so that you really force yourself to understand when looking at those representations, like what's interesting about this? How did they decide to collect this? If I wanted to prove something else, what else could I collect to go next or do next, that kind of thing.
Great.
I guess I should probably mention that at some point I got a random email from Tim Brown, and he sent me this link to elementsofai.com, which is apparently a pretty good class on learning AI. So you might want to check that out too.
Oh, that sounds awesome.
Yeah.
Just another random email from Tim Brown.
Yep.
Thank you all so much for the opportunity to kind of talk about design and data and design. We'll stick around kind of after the break for like a little bit of informal Q&A, but it's been a real pleasure. Thank you.
Thank you.